Take it back a notch here, sorry. So welcome everybody. I'm here to talk about Vault, HashiCorp Vault, using it along with Google's serverless solutions. I'm a principal software engineer here at the New York Times, working with some of the colleagues of mine, what you just saw. I've been working at the New York Times, see you guys, for about 10 years, or 7 years now, sorry. At the New York Times, I've been writing Go and putting it in production since 2013. I use this nice little avatar here to represent myself around the company. I'm one of our open source maintainers on GitHub NYTimes. I kind of maintain a project called Gizmo and a couple other tools. And I'm going to cover another tool that we open source that I maintain later in this presentation. I'm also a games developer for the New York Times. I work on the crossword and some of our newer games and game prototypes that have been churning out over the past few years and gaining in popularity. And if you ever want to reach out to me, that's my Twitter handle. Right. So what we're going to cover today, we're going to cover basic definitions of the different platforms here. And then we're going to walk through basically how New York Times developers will interact with our Vault installation that was mentioned in the last talk here. And then finally, just like some examples of how you can use this new open source tool we have with the Go programming language to interact with Vault, and kind of how a dev workflow kind of should interact with the whole system. So first, what is serverless? I'm going to take a New York Times definition on this one. We have our CTO, Nick Rockwell, put out a nice Medium post a little over a year ago at this point, year and a half maybe. And he has this nice quote here that talks about kind of like the abstract idea of how he defines this kind of buzzword of serverless in the world of cloud infrastructure. And that serverless is any platform that provides utility while completely abstracting scaling and reliability. So in that term, in that idea, serverless is basically even like a CDN. So we consider Fastly a serverless type platform. But in terms of this talk, as we're talking in Google, I'll be discussing two serverless platforms, as we'll call them, is Google App Engine and Google Cloud Functions. Now, we're talking about them separately with Vault here because they are at a different paradigm than what most other Vault users may be interacting with Vault. We can't just run a Vault agent and we don't have any opportunities for have something like a sidecar, since generally these are single core processes that we have access to, and there's very limited scope in what we can run within there. So generally we need some way for these apps and these infrastructures here to reliably access Vault on their own within the app layer. Right, now on to the other side of things. Something that's probably been covered quite a few times already here on this HashiTalks, so I'll cover it pretty quickly. But what is Vault? To me, it's, as an application developer, it's something that I store tokens and passwords or certificates in, and then I can access it easily using either a really nice command line utility or HTTP APIs that are wrapped up in some kind of nice library, perhaps. Now, at the New York Times, there's a lot of times when we're trying to figure out, or when people are trying to figure out where to put their secrets, and we're trying to like guide them on the path of why even Vault should be the proper choice. For us, first off, why not just throw it in our code on GitHub? The big thing is that that'd be a honeypot, and that somebody could just grab all of our code, have our secrets, and then be able to do whatever they want and act as us, which is certainly not a good thing. The other option is why not use one of the cloud offerings that usually either Google or AWS offers, which is KMS or key management systems. The big thing we didn't agree on that, at least with our kind of setup, is number one, it's not quite as auditable, since generally a lot for our setup with Google Cloud is that generally each department or team might have its own set of Google Cloud projects. So it's a little bit, that makes the problem for secrets monitoring and auditing a little bit harder when you have so many places to keep your eyes on. on the other side of things, it didn't really work with our Git workflow, as you'll see, as we'll talk about later with how we kind of interact with things. But it just didn't seem to work with our tooling as well as we hoped it would. Finally, you saw in our previous talks that we actually use Drone as a CI/CD tool at the New York Times. And while it does have secrets offerings, one of the big reasons why we would not want to use it for secrets, for most of our secrets, is that it would be another honeypot. But I think the scariest thing here, which is in a call for some scream cat emojis, is that it does store secrets in plain text in its database underneath the hood, which is not necessarily good because it makes getting the secrets very easy, if that makes any sense. Right. So how do we manage Vault at the New York Times? We use a lot of Terraform, but to kind of smooth out the process of Terraform and Vault and our tooling, we have Vault uses a tool that we built in-house called Goblin. It has this nice little mascot, as you can see here. And it hooks into our Terraform, but also hooks into all of our GitHub teams and repos. And that's kind of how you'll see here in a little bit how we kind of control access to different secrets and things like that. So next is kind of like an onboarding, is if we were a New York Times developer and we were going to be using this platform for the first time, and we wanted to make sure that not only we are set up to access Vault, but also our Google project would be set up to access Vault. So it's just kind of like a set through of things. The first thing any developer should do, or hopefully does when they start using a new system, is to RTFM, or read the manual. And so the nice thing for the New York Times is that our delivery engineering team, our SREs, and our tooling team, who actually maintains our Vault setup, actually has built a nice set of documentation. Right now, it's on GitHub, but we're considering moving it to some nicer tools like MKDocs or something like that. But it's the DV Vault Guide. And within the DV Vault Guide, we offer guides and other things like that, and how-tos on how people can interact with Vault and setting up their tooling to interact with Vault. So as they walk through this guide, we'll have a getting started, usually a tutorial. And that leads us into really the first thing that our developers need to do to have their system set up to interact with Vault, which is to set up a GitHub Personal Access Token, or PAT. The nice thing about our guide is that it leads our developers to this handy link that will take you directly to your GitHub settings page, and it will actually allow you to build a personal access token with a very specific scope, a very minimal scope that will basically be what Vault needs to know about you, to see what secrets you have access to. So if you'll see down there, it's just a read-only access for our org. So it can see which repos and which teams you have access to, because that's where we'll tie our secrets to underneath the hood. Once you have that personal access token, you don't see it right, you put it on a known location on our laptops. And as you'll see here on the right, it's like underneath our home directory and a config directory. And what we'll do is to log into Vault, we'll use this nice handy dandy Vault command line utility. And you can just cat out that token and use the GitHub method. And hopefully, if all of your configuration is set up, you'll get this nice success message followed by hopefully a list of roles and things like that you have access to that Vault installation. So now that we have access from our laptops and our developers have access, the next step will be for our developers to give Vault access to our Google Cloud projects. Now, to do that, to kind of follow the theme with minimized scope, as we like to do with security and things like that, the first thing we'll do in the Google Cloud platform, this is a sample project I have here, is to create something called a role. So within Google Cloud platform, underneath the IAM section, you'll find roles. And within role, we create a new role that has just a name, Vault Service Account Check. And what this role is going to do is going to give our Vault installation bare minimum access it needs to verify identities of service accounts and cloud VMs within this Google Cloud project. The key thing about making this role here at the bottom is basically these three permissions. There's a compute instances get, and what that will be is for the more serverful, for a bad term, but basically for our non-serverless users that are on GKE or GCE. But then the bottom two permissions are what we actually need for our serverless environments to log into Vault and access Vault, which is the IAM service account keys get and service accounts get. As you'll see later, the idea is that we'll use Google's IAM services and cloud services to actually generate identity tokens, of a better term, and use those to log into Vault. Right, we've set up our role here. The next thing we need to do is actually apply that role to something. And to do that, within the same part of the Google Cloud Console, you can just go to the main part of the IAM section. And within there, we'll add a new member to our Google Cloud project. And to do that, we'll add a service account, a known service account that our Vault installation is using. And we'll add that as a new member to our Google Cloud project with that role we just created, that Vault service account check. All right. That sets up Google Cloud or Vault to access our project, but now we need to set up things the other way, is that we need to enable our Google Cloud service account to log into Vault. So on the other side of things here is that what we'll use from an App Engine and Google Cloud Functions standpoint is we'll use the App Engine default service account, or at least by default, at least. To find that within the same section of the Google Cloud Console and IAM, usually it starts or it has the word app spot within it. So you can look for that there as a quick filter. And within there, once you've found your default service account, the one thing we need to do for this is actually we need to enable it to create those IAM tokens. So the role for that, as you'll see down at the bottom here, is service account token creator. Simple enough. Once that's added, it's kind of like the full loop. Now, the last piece of the puzzle from the New York Times standpoint is now that we've given everybody access to everything, we need to tie it together and actually enable our Terraform and Goblin to actually know that, number one, secrets are enabled for a specific path, but also these different actors actually should have access to these secrets. To do that, I'm just going to show like a little example of what a pull request that something that we might include at the New York Times on our gcp-vault Terraform repo here. And what this is just a repo of Terraform that works with our Goblin setup. The key thing here, as you'll see, is that the Terraform is broken up into two pieces. There's repos and teams. And that's the idea is that our secrets are either associated with a specific GitHub team or a specific GitHub repo. And the idea is that if you have access to that code, you should also have access to those secrets, if that makes sense. And so inside of one of these, this would be one of like the repo Terraform files. The lines here we have is just like 5 lines of Terraform that are using a bit of like a higher level base repo Terraform config that our Vault team has set up together, so that all we need to supply as developers when setting this up is to create a new module that usually is called the repo, my repo. And then we just need to give it, number one, the name of the repo, my repo, and then the organization, my GitHub org, or whatever your team is working on. So that at some point will actually set up a specific path within Vault where our secrets will be enabled that are kind of in a convention related to this GitHub account, and it will enable people who have access to this repo, admin access, if they have admin access to the repo, to manage Vault secrets for that stuff. The next thing we need to do is to create a policy. Now, this policy is going to be used by our service account, and what we need to do here is that we'll basically hook up on line 8 there our repo that we mentioned before. And then the critical thing here is on 11, that path of where the secrets are going to be. That's just a convention we kind of follow. And the critical thing on line 12, the read-only capabilities. So this is saying we're creating a policy where somebody can access the secrets, but they can only read them, which is generally what we'll want from our infrastructure. So the final piece here is that we'll tie that policy together with the Google Cloud project and our GitHub repo. So this is like the final key piece of the Terraform here. So we'll create another module that is importing some other base GCP IAM Terraform that our Vault team has set up on line 18. Once again, lines 19 and 20, connecting to that GitHub repo. Next, we actually connect a specific project. So this would be if you had a Google Cloud project, like in that one example, it was like NYT, Golang, blah, blah, blah. This would be in here. And then the specific service accounts we want to have access from that project. For the example here on line 26, I'm using the AppSpot account, so this would be the default service account for App Engine. But if you wanted to have some additional service accounts to have access here for something like integration tests, you could put them in the array there. Finally, the last thing on line 28 is that we're tying all of that stuff together with that policy we created on the last slide, so that specifically this project and this service account has access to this GitHub repo's secrets, and it's read-only. Obviously, that's a lot of a mash, and it's a lot to ask for a lot of our developers, so we're working over time, and we'll hope to eventually like smooth and automate this stuff out a little bit more. But so far, it's making lives a little bit easier. So after you've our general flow of things is after you've made your Terraform updates, you just make a quick pull request against our repo, and then hopefully one of our Vault managers, like Sean, as you saw in our last slide or our last talk here, will look over your code, find any follies, and give it a blessing and merge it after a few rounds of tests and everything like that. And then the secrets are enabled. Right. Now that was all the kind of setup. The scene was kind of painful, but the nice thing is that that will only take a one-time setup per project or maybe per repo. And then from there, it should be kind of cruising. So now at this point, it comes down to how do we actually use Vault from a development standpoint? How do I use it locally? How do I use it on the cloud? And for that, this kind of hopefully will show like a little bit of a diagram of how at least the cloud flow might work. This is actually pulled straight from the Vault documentation if anybody's familiar with it, but this is the IAM flow. And the idea is we don't have a GCE or an actual Google Cloud VM to verify our identity. So we need to use this default service account and the IAM services. So what we need to do from an instance or an app standpoint on App Engine or Cloud Functions is that on startup, in some way, we need to figure out what our default service account is, find those credentials, and then, as you see at the top here, number one, call the Cloud IAM service of my project to generate a signed JWT with some known payload that's in the contract with Vault and the Vault plugins. Once we've received that JWT, we have to then pass it along to Vault, as you see there, number two. At that point, Vault needs to verify that that is a valid JWT and that you are who you say you are. And so it'll actually use that service account we wired up earlier to then reach back out and full circle to Cloud IAM, where it will then verify the payload and then hopefully return an access token so that that client in our app is able to fetch secrets. After all of that, finally, we can actually fetch our secrets and do what we need to do and boot up and get stuff done. That's a lot of work, and it was a lot to ask a lot of our developers to write that every single time. So what we ended up doing is open sourcing a tool. We did it a few months ago, I believe, at this point. Seems to be received well by the Googlers and Vault maintainers we've talked to at least. But the tool is called gcp-vault. Not a fancy name, I know, but that's how I like to name things. And that the idea is that this tool wraps all of that stuff you saw in that last slide into a single function, get secrets, if that's all you need to do in the simple secrets fashion. It also has been extended a little bit for more advanced scenarios if you needed to do versioned secrets or if you needed to put secrets back into Vault quite as simply. Basically, we've hoped to simplify things a little bit for people here. The nice thing, though, is that this is not only considering using this library when you're in the cloud, it also is meant for being used when you're working locally. So the idea is that if you're using something like our GitHub tokens to actually maintain local access to Vault, this plugin or this package should hopefully allow that to all work quite seamlessly. So to show it off a little bit, I'm going to walk through a few of the examples that are actually going to be found in this repo. So if you're curious and you want to actually try it out, feel free to clone the repo, pull it down, and look in this examples directory, and you'll see some of these nice things. Now, for the sake of brevity, I'll warn you, removed most of the error checking, as usually would be done by a good gopher, which is what I hope I am. But you know, slides in real estate space, right? So as you can see in here, this is what we're going to do for a cloud function. On cloud functions, if you read the documentation with Go specifically here, I'm sorry, this is for Go, not other languages if you're here for that. But with Go, on cloud functions specifically, you don't have the ability to have something like a main function or something that would allow you to build a binary or something like that. So what they do offer is just if you need to do anything on startup, is that you need to hook it into the init function in Go, and that will just get called, you know, as the system is booting up. The problem with that is that you have to use something like a global variable if you want to initiate something and then reuse it within the cloud function. So to do that, at least in this example, we have a little init client function, which we're calling on line 16 there. Within there is just kind of the guts of what you do when you interact with GCP Vault. The first thing we do on line 22 and 23 is to declare a config variable, which we'll use to basically tell Vault how to fetch or GCP Vault how to fetch the secrets and log in. We use a little env config library there that will quite handily scan the environment variables for specific things and inject them into our config object if they match. And then once we have our configuration, line 25, we call that get secrets function. It does the magic of doing whatever method it needs to do to log into Vault and then fetch those secrets. It returns the secrets in a map string interface, which is what the underlying Vault client does in case you have secrets that are not of type string. But then what you'll see is that all of these examples within GCP Vault, they actually use a little client that I built that allows it to access some of our public APIs for NY Times developers. And in this case, it's like a top stories client or something along those lines. But in order to init the client, what we need is an API key that we've pulled out of Vault. And in line 27 there, we're knitting our client for later use. Now, the real guts of the cloud function itself, in this one, it's actually a little HTTP handler. And in this one, if you're familiar with Go, all we need to do is call that global variable on line 30, that client we initiated, to actually get whatever we're looking for. And in this case, it's top stories. And if it was successful, because our client was initiated properly, we can respond as JSON in line 36 there. Simple, tiny little cloud function, but quite powerful in that it was able to, on startup, quite easily fetch secrets from Vault. Now, on the other side of things, in the other realm of serverless that's a little bit more server, is App Engine. And in this scenario, we're going to be talking about the new second generation App Engine, which makes life a lot easier than the prior first generation. This is still in beta, but I think if you're starting out on App Engine, this is probably the tool set you should start with. In this scenario, it's actually a bit more advanced. It's using our Gizmo framework underneath the hood. And with that, we encapsulate everything in a new service within our main so that we don't have to have global variables. So a new service will look very familiar. We just inspect the environment, get our secrets, and then initiate our client on line 27. The nice thing here is that client is actually an instance variable or an instance field on our service. It's not a global variable, so that when we have wired up an endpoint for something like this SVC example, top stories, we can eventually just once again call that client that's on our injected service there and respond with similarly in JSON. Right. So that's, all kind of hand-wavy thing, but like how would it actually work from a development standpoint? the final thing I got to show here at least is kind of a makefile. So when I'm running this locally, what I'll do is first, generally, I have this dependency that I put in my makefile. It's called Vault, and that will do that familiar Vault login command using my GitHub personal access token on line 21 there. And then once that's completed successfully, Vault actually puts a short-lived token that's a result of a successful login also on my local computer, as you'll see there on line 25, and a Vault token file. So when I actually want to run, I just need to set 3 environment variables to actually access Vault. One is on line 24, my Vault address, which is just going to be where my Vault installation is hosted. 2 is this Vault local token, which tells Vault that, like, hey, I've already logged in, just use this token directly to access Vault. That's one of the nice things our plugin recognizes and uses underneath the hood. And then 3, the one thing that will be kind of really common here is the Vault secret path, which is actually telling the GCP Vault tool where to fetch these secrets from once you've connected to Vault. And then it just starts up the server and hopefully everything plays nice. On the other side of things, when we need to deploy, the config looks slightly different, but the code is the same. Now, this is an app.yaml file, which is like the configuration you will use when you're deploying an App Engine service. And in this case, we use the thing that's really important here are the 3 environment variables we set down at the bottom. The first on line 8 is going to be very familiar. It's that a Vault address, wherever our install is. Line 9, same thing we saw before, the path in which we need to fetch our secrets from. And then line 10, this is a new one. It's a GCP IAM role. So this is a role that was generated through some kind of convention from our Terraform. But this is also telling the plugin that, like, hey, when you start up and you want to fetch the secrets, you actually should probably be on GCP's infrastructure right now. So try to look for your Surface account and then use this role to log into Vault. And if all goes well, everything starts up and your service is ready to return whatever JSON you're ready for, and your service is able to do what it needs with all the secret heads. Right. Just kind of wrapping up here as we kind of finish up. Today we've covered what is serverless from a Google perspective and from a New York Times perspective, App Engine and Cloud Functions. We've covered what is Vault and why we use it at the New York Times. We've kind of given you like an intro to like how we ramp up our use with Vault. And then finally, we've walked through how we interact with Vault as a developer with our tooling and everything like that. Well, that's all I had to cover. Thank you. Let's see, do we have any questions? Looks like, yes, we do have some questions. Let's see, how do we handle policies managed in Vault, different projects, policies, achieve ACL? So as I mentioned before, our Vault access is managed through Terraform and policies wrapped around our GitHub accesses and things like that. So if you have admin access to a repo, or if you are a member of a specific GitHub team, you'll have access to those related secrets. And we basically build our paths in Vault around that ACL. I hope that was a reasonable answer, at least. Yeah, anybody else? No other questions? Excellent.